Hi. What's up, everybody? This is Kris Nova coming at you live from the TGI studios here in downtown Seattle, Washington. Happy Friday, everyone. How's everybody doing? Let me pull up the chat here so we can do my favorite part of the day, which is looking at the chat. Oh, the chat window's messed up in my screen here. Let me see if I can't fix this really quick. 1 second. I don't know why it always wants to do this. So I'm running on a computer I don't normally run on. I accidentally brought my personal MacBook to the office today. So we'll see how this goes. Let's make sure we get this nice and balanced. There's that, and let's go up here, and let's bring this up there. Sorry, I know this is going to be annoying, but welcome to TGI. Let me adjust my OBS for everyone. Okay, that should be a little bit better. Tell me what folks think. Let's see. And let's go ahead and start saying hi to chat. In chat, why people tell us if the new chat window looks okay, if you can even read it or not. It's kind of hard for me to see what you're seeing on your end over there on the other side of the internet. But anyway, it's good to see you. So let's see. First this week was Olav. Hi, Olav. How's it going? Happy Friday from Denmark. Basmark says good evening from Lagos, Nigeria. Ivan says, let's see, good evening, geeks. Martin says, good evening, everyone from Rotterdam. Heptio says, good afternoon. We have Duffy on the line today helping out. So shout out to Duffy for helping me out. George is taking the afternoon off, and we're hanging out, having some fun. And Duffy got to see, I think this might have been the first time that you got to see like the Kris Nova behind the scenes pre-TGIK when I just stayed in here and talked to myself for half an hour. It's really quite funny. I kind of want to start recording it just so that we can like have like the TGIK bloopers, because it's just me in here like typing and just talking to myself without the other camera there, which is funny because it just gets me in like the mode for TGIK. But yeah, it's probably looking insane to most people. Anyway, Heptio says we're getting started. This is Duffy. Sandeep, hello from Poland. TGIK. Martin, hello from the Netherlands. Heptio says this is the HackMD, which we'll pull that up in a second. So that's the HackMD for folks at home who don't know what that is in the chat. And in github.com/heptio/TGIK, you can find a link to a HackMD that I will pull up, which is basically a live README file for GitHub that we can all edit together. So feel free to take notes or write things down, and we can all collaborate on that while we do our TGIK live. Suresh says, hey guys, and also girls too. Chat says, chat looks good. Louise San Martin says, good night everyone, greeting from Amsterdam. Happy to be here. We're happy to have you, Louis. Good to see you. Also, I apologize if I mess up anyone's name. I try my best, but I'm not always the best at pronouncing people's names. Miguel says hello from Mexico. Hola, Miguel. ¿Qué pasa? Hello from San Francisco. Hi, Aaron. Hello from Johannesburg. Hi, Michael. El chat está funcionado. Chat is up and running. Gracias, Louis. Hello from India. Hair looks great. So funny story here. Amy Van Groningen, she just commented in the chat, wanted to give her a big shout out today. She's been helping me with my TGIK intro and outro game, so we really want to try to step up my welcome to TGIK, everybody. And so Amy's been giving me personal guidance on that, and she joined today just so I can make her proud. And also, I guess, to compliment my fabulous hair. Roy says, Norway. Trondheim says hello. Steve Sloka says, happy Friday, everyone. Good to see you again, Steve. Thanks for joining. Love to see you here. Okay, so let's pull up this HackMD and get started for what's new in TGIK this week. So we go over here. So again, there's a link to this in the chat if you want to go and pull it up. But it's just this website, hackmd.io. And then on the left side here, we have, which is basically just like GitHub style markdown. And then on the right side, we have a rendering of this. And after we are done with the episode today, we will merge this into github.com/heptio/TGIK. And you can come in and you can see that we actually have all the episodes listed here in the episodes directory. So anything you type will get merged upstream. And that's how we like to do things around here. So let's see, I got somebody messaging me. Awesome, it's Amy telling me that I'm killing it. Thanks, Amy. So let's see, go back to that chat room. Okay, so here on the left, we have table of contents. So we try to do like a what point in the video you can do whatever. So if there's any major points in the video that you think folks would want to jump to, feel free to add a line here. And then these, if you just use this format, it'll automatically build a link whenever we push it to the repo. So you don't have to worry about creating a link or anything, just the time, and we'll take care of the rest. Jan says, hello from Palo Alto. Nicholas is here. I'm here, and I'm looking Duffy directly in his face. That's awesome. Where are Nicholas? Oh, so Nicholas and Duffy both work here, obviously. Where are y'all hanging out at today? Are you like together at the office somewhere? Because I don't think you're here. Maybe you are. I don't know. There's not very many people here in Seattle today. Christopher says hello from Germany. Yeah, I think that's all the chat messages. So anyway, let's see. We've got two things to look at. We have the last week in Kubernetes, and then we have Kube Weekly, and Duffy was kind enough to put some of this stuff together for us. So let's go through and check some of this out. And then also, I just want to mention, while I eat one of my M&Ms here, so this week has been a crazy week for me. I've been super busy. So this is one of the few episodes that I'm actually going to be going, like I've never touched Gloo before in my life. I know enough about it to know that we can do Ingress, and we're going to be figuring everything else out live. So you're actually going to get to see like the honest, like me figuring stuff out on the fly without any work set up. All I've done so far is just fire up a Kubernetes cluster, but we'll jump in my terminal and look at all of that stuff later. Nicholas says Bellevue office. Oh, okay, you guys are in Bellevue. I'm sorry, you folks are in Bellevue. Louis San Martin, Glow sounds a lot like Glosoli, as in cigarros. Okay, so Louis, you win the contest today. So every week for Kubernetes, if you look here, we have a title card, like the one I just showed you. And we always pick out an image that's relevant to like whatever we're doing our TGIK on. And it's like this inside thing that we do. And if you've been watching TGIK, you may or may not have picked up on it. A really great example was when we did Spring Boot, there was a picture of a pair of boots in the background. And like when we did Docker, there was like Docker containers and so on and so forth. Anyway, so for this week, again, we had this picture, which is a picture I took with my fancy camera while I was in Iceland, for precisely that reason that Louis mentioned down here. The word for overjoyed in Icelandic, if you look over here, it's actually pronounced glö, or it's the closest word in Icelandic to glue, and it means overjoyed. So I took my favorite picture from Iceland, and that's the background today because it means overjoyed in Icelandic. So glue means overjoyed. So today you learned some Icelandic, and the band Sigur is actually from Iceland. So yeah, Louis was the first one to get the reference there and why we picked that picture for this week. So wanted to call that out. So anyway, we're going to go through this week in Kubernetes, then we're going to jump into Gloo, and I've got a bit of a surprise kind of twist to the what we're going to be doing today, but we'll talk more about that in a moment. Okay, so first things first, new scope and KK. I'm going to pick on you, Duffy. I always make it a point to not use the abbreviation KK. Just to help newcomers to the project who may not know exactly what that means. And in most cases, I really like to do actually super verbose as possible so that everybody knows exactly what we're talking about here. And that way we don't create any confusion while we're showing people what's going on. So new scope doc in github.com/Kubernetes. Let's see what's going on here. Oh, so this is the community repo. Oh, bam, there we go. Steve Sloka says, Glow sounds a lot like Glosol. And then Nicholas Lane says, Vi Bellevue till Altschau, Paul Fazone. So I think that means they're in Bellevue hanging out with Paul, which is exciting. That's really cool. Hi to everybody in Bellevue, and thanks for speaking Icelandic for me. I appreciate it. Okay, so anyway, Kubernetes scope. So let's see, there's one contributor. So Brian Grant added this on January 30th. Heptio says, yep, I agree. Presmek says, greetings from Las Vegas. Awesome, Presmek. I will be in Las Vegas doing the Kubernetes meetup in a couple weeks. I just tweeted about it, but I'm going to tweet about it some more, so follow me on Twitter for more. But I'm going to be doing, basically I have the whole night at the meetup to myself, so they're doing like an evening with Kris Nova. So we're going to do some virtualization demos, we're going to write some containers, and basically just do like a live Q&A. So if you want to come and hang out in Vegas, I'll be there for an evening, and it should be a lot of fun. So hopefully you can make it out, and hopefully you can tell some folks that we will be down there having a party. Okay, so Louis says, yay, going to visit Iceland for the first time in May. Awesome, May is a fabulous time to visit Iceland. Make sure you bring sunglasses because it will be sunny almost the entire time. Okay, so Kubernetes scope. So Brian Grant merged this in on January 30th. Okay, so it's relatively new, Purpose of this doc, clarify factors affecting decisions regarding what is and is not in scope for the Kubernetes project. Oh, wow. Okay, so this is a big one. This scope of Kubernetes is like, I feel like we've been talking about this for the past 3 years. And this like starts to allude to the conversations that we used to have about what is core and what does core mean, or what is a first class feature, or what is a second class feature, what do we support, what do we not support. And there's always been sort of these blurry lines around what is, where Kubernetes stops and where like the rest of the ecosystem picks up, because the whole point of Kubernetes is to make everything modular and like stick pieces together to build a more complex system. But like, what are the boundaries for Kubernetes itself, and what actually defines what is Kubernetes and then what is everything else? And that boundary is not as clear as you would think it is, especially when you start looking at things like DNS or container runtimes. Those can vary from cluster to cluster and from environment to environment. So does that count as Kubernetes or does it not? So anyway, I think this doc is going to come through and kind of calls this out line by line. Yeah, so we've got scope for the GitHub Kubernetes project. Okay, so it's all the GitHub orgs, Kubernetes SIGs, Kubernetes client, other GitHub orgs. I'm assuming this is GitHub Incubator. We have release artifacts. So all of the Kubernetes releases are owned by the project, which is good because Kubernetes releases are actually super awesome and surprisingly stable. Well, the release process is. The release itself isn't always, but that's okay. Functionality layers, other inclusion considerations. Okay, the project is a large, complex effort. Okay, so if you're interested in learning more about what exactly is Kubernetes and where it starts and where it stops, there's actually a document on this now, so we can come and point to this if we ever have any confusion about what is and isn't in or out of scope for Kubernetes, and what I'm effectively thinking of as the core components of Kubernetes, which again, these are things like the API server, the scheduler, the controller, the kubelet, etcd, all those good things that make Kubernetes nice and happy. Okay, so that's really cool. We have Kubernetes scope. So this next one it's a bit wordy, but basically, I think what's happening here is we made a guarantee that for readiness and liveness probes, which these are how you would go through and validate that your pod is running and behaving how you want it to. So this is a way of like building a simple HTTP server that Kubernetes can ping, and based on how this HTTP server responds, we'll either consider your pod healthy or not. And we had a guarantee that all HTTP response codes between 200 and 400, which 200 is success, 300 is redirect, and 400 is error on your end, and 500 is error on our end. So anything between 2 and 400 in the HTTP spec, which you can go and like Google HTTP spec and look all these up, would be considered a success. So basically all we're changing is the way that the 301 and 302 redirects behave and how the kubelet responds to that. So there's a little bit of a consideration here if we pull this up. In some rare cases, this might actually change the behavior of what your systems are doing. But for the majority of folks, this is just going to be a nice to know and not a need to know. So you can come through and read this if you want to actually see how these HTTP redirects will behave. That it's going to be based on the host name that you're using. So redirects to the same host name as you used originally will still not be followed, but a redirect to a new host name will be considered a success. So that's what's going on with liveliness probes and, readiness probes. So let's see. Doing a check in chat. Okay. No, nothing in chat. We're cruising right along this week. I'm gonna grab another M&M, and we can. I'm eating this M&M. Let's pull up Q Weekly here. Okay, so like I want to do a show of hands. I wish we could do like a online show of hands so I can like get a feel for what they do and don't know on every episode, because I don't want to like go too far or too deep, or I don't want to assume too much. Anyway, Q Weekly has been around since I've first made my first commit to Kubernetes forever ago. I think I remember the 11th one of these, I want to say. But anyway, we're up to 165 now. And every week, this is a really great blog that puts together all of what's kind of happened in Kubernetes, and it just consolidates that, and it just sort of acts as an index for the week. So this week, we had a very exciting post, the what and the why of the cluster API. This is by Tim St. Clair. He's one of our engineers here at VMware. He is one of the chairs for SIG Cluster Lifecycle. He's a really great engineer. I've been working with him for a while. He's on the steering committee. Tim's awesome, and he wrote this really great, very detailed definition of the cluster API, what it is, where it came from, and why it's here. And he's even got, we all know how much I love a good graph or a good chart, but he's even got some good charts and graphs in here that explain concretely, you know, we were just talking about this, but what is Kubernetes? And what are all these other tools that are above or below Kubernetes, and where does the cloud provider fit in? And he talks about how the scope of kubeadmin may or may not impact the scope of Kubernetes, and where the cluster API fits into all of this. The cluster API is a project myself and a handful of folks over at Google, Robbie, who's no longer on the project either, and Jacob and Weston and a few others. There's a blog on I think the Heptio blog that tells the history a little bit. But basically all the cluster API is it's a declarative way of managing and mutating Kubernetes infrastructure. So sort of doing things the Kubernetes way. So instead of saying, I'm going to run a script to give me a new Kubernetes cluster, you say, I'm going to create a CRD that's going to define my cluster, and then there'll be some controller that runs somewhere, probably in a cluster or in its same cluster, that's going to then go and reconcile whatever that definition was and continue to reconcile that over time. That's like the big win here, right, is we get that continual reconciliation. So if something does happen or something does break or something does go wrong, the goal of Cluster API is to have your infrastructure sort of refix itself to the way you originally declared it. So that was like the big win of Cluster API. And this talks a lot about that in a lot more detail than what I was able to kind of spit off here. But that is Cluster API on the VMware blog, so make sure you go and check that one out. All right, so coming up next, we have, here it is, shout out to Tim St. Clair. Shout out to Marco Madrinek. Okay, so Marco, another really good friend of mine, he is one of the maintainers on Cubicorn, which is a project I started 2 years ago? I forget, maybe 1 year, I don't know. It's been a minute though, it's been around for a while, and Marco's been nice enough to help out with the project, especially after I got so busy here in the last year and a half or so. So anyway, Marco wrote this blog. I think he works for our friends over at Lutzi, who are based out of Berlin. He works there now, and you can come through and you can read about running Kubernetes in a CI pipeline for integration and end-to-end tests. And if you want to learn more about this, you can come read Marco's blog here, which he always does a fantastic job at being very thorough in all of his work. And also we did a TGIK live at KubeCon last year, and we did a TGIK episode on Kind where we went through and actually showed folks how you could use Go test to spin up a Kubernetes cluster, write a unit test against your cluster, and then tear it down and plug that into CI. So this is probably a similar concept, probably handled a bit differently and detailed step-by-step instructions on how to make that work. Okay, let's see. So Khalid says, hi guys from Dubai. Hi, good to see you. And then we have Michael who's waving. Hi, Michael. Good to see you. Thank you again, everyone, for joining. I know it's a weird time for some folks in other parts of the world, and I think the majority of our audience here is not from the US, so it's always great to see folks who are spending their Friday nights or Saturday mornings or whatever time it is for you, hanging out here live with us at VMware. So thanks for joining. So anyway, there's Marco's blog, and then we want to give a shout out to Paris Pittman, who's the community manager for Google, another good friend of mine. I seriously feel like Duffy picked all of my homies from Kubernetes for the Cube Weekly this week. But Paris did a retro and look forward to on the Contributor Summit that's coming up. So Paris and George here at VMware work really hard on these Kubernetes contributor summits. They've evolved quite a bit over the past couple of years. That started out originally as like a couple of us sitting in a room who got some free t-shirts, hacking on Kubernetes and cutting a release live at KubeCon, to now this way more advanced, way more formal. We actually can go and be productive, and it gets recorded and we take notes, and it's like a very exciting part of our year when everybody gets to get together and sit in a room and talk about Kubernetes and the direction the project is going. So none of this would be possible without Paris. So a big thank you to Paris. We're all very grateful. And then you can also see here's George, Paris, Bob, Jeff, and a handful of others. Josh Burke, he's over at Red Hat. He's another great one. Jason D. Tiberius, Ihor, Tim Pepper. A lot of really great people here, a lot of really great names. So thank you so much for everything y'all do. We really appreciate it. Let's see what's going on in chat. Shameless plug, I'm demoing Cluster API AWS provider at a meetup in Seattle on the 27th. Okay, so this is Ashish. He just mentioned this in chat. Hi, Ashish. It's good to see you. Also, I'm pretty sure I'm pronouncing your name right, but correct me if I'm not. I apologize. But yeah, Ashish is doing a demonstration on the cluster API. He's been working hard in that project for quite some time now, and I guess he's doing a demo of the cluster API AWS provider, which is something that we were working hard on at Heptio. So it'll be exciting to see how that's up and going. We did a TGI on the cluster API for AWS quite some time ago, so I'm excited to see how it's evolved since the last time I looked at it. Ashish, do you know if that's going to be recorded anywhere? And if so, can you share a link in the document here so that folks can find it later after the fact? Because I know a lot of people come back and watch this over the, sorry, I have bad bones, over the coming weeks after we release it. So anyway, shout out to Paris. Thanks, Ashish. We learned about the word glow in Icelandic. And then now let's start talking about the reason we're all here, which is Gloo. So Patrick, he's one of our engineers here at VMware, typed this up in Slack, and I don't think he realized I was going to quote him on this, but it really was a fantastic little snippet that he did. Ashish says, yes, I'm pronouncing his name right, so that's good. So I just want to read this really quick. So basically, Istio, Ambassador, Contour, etc. are all just ways of configuring Envoy on Kubernetes. We're going to talk a little bit about what that means more concretely in just a moment. But Gloo decomposes all of that and that process down into more fundamental types. And this is the same thing that Kubernetes itself does, is take this complexity and break it down into like small, convenient little interfaces that you can replace with various other pieces of logic, but the interfaces always stay the same. The Linux kernel itself also behaving the same way. So Gloo did this, but with networking built on top of the Envoy service proxy from our friends over at Lyft and our friend Matt Klein. So you can come here and you can actually see this gloo.solo.io.dev, and you can see how it breaks all of this down to bind addresses, domain sets, and then routes and TLS configs for each of your domain sets. So it's sort of a logical way of breaking down how you're going to configure your layer 7 networking. So this is exciting. Ashish says, if it's recorded, I'll share. Don't know if it's going to be recorded. Okay, so yeah, if you get it, feel free to open up a PR or you just ping me and I can help you get a link in. I'm sure folks would be curious to see your demo if it does get recorded. So anyway, going back here, that was sort of the TLDR, quick and dirty explanation of Gloo and how it relates to Envoy. And we all know Contour is one of the projects that Dave Cheney, one of our star engineers here based out of Australia, has been working on. He's at VMware now as well, and Contour does this similar thing. So this, in a weird way, is sort of a compare and contrast between Contour and Gloo, and we want to see some of the differences and similarities between the both of them. But yeah, basically it makes it a really easy way to build Envoy configuration services. In other words, it provides an abstraction on top of Envoy that makes it easy for engineers to interact with. So it sort of boils it down and gives you a toolkit for working with and around Envoy. And Contour, of course, does the same thing. Okay, so we're going to pause there with Envoy and Gloo in Contour for just a moment. And we're going to go on this other little tangent, and then we're going to tie the two back together. So this other tangent here is on Twitter. I forget who it was, but it's on my Twitter, and I'll retweet it after the show. Somebody had mentioned, hey, will you check out the new Kubernetes dashboard? And I'm like, yeah, totally. I love a good Kubernetes dashboard, and I always think it's very rewarding at the end of a TGIK to get something up and running in Kubernetes and actually be able to go and use it. So the Kate's dashboard here, you can find it at dockerhub/hrbranson/Kate's dash. You can see here's a screenshot of it. It looks pretty similar to the old one, although it looks like a little bit more like JavaScript-y, like fancy or whatever, like charty graphy. I don't know if there's an official UX term for that. I'm a kernel engineer, so don't get mad at me if there's better words to be using there. So basically, you need a running Kubernetes cluster. You need a metric server installed. It's optional, but strongly recommended. I think we might skip this step today because we're just going to show a demo. And a Kubernetes cluster configured for OpenID Connect Auth, also optional. And also, we need, and this is where things start to tie together, if you look down here, there is an ingress defined, and we all know that if you define an ingress, you of course need an ingress controller in order to make this run. So what better ingress controller to demo the Kate's dashboard with other than Gloo, the ingress controller built on Envoy. So as I was looking at checking out the Kate's dashboard here, I was like, trying to also come up with a project that we could use Gloo to run on, and then these two just sort of fit magically together. So we're going to do both. We're going to check out the new Kubernetes dashboard here, see what it's all about, explore a Kubernetes cluster, and we're going to get this Ingress down here at the bottom up and reconciling using Gloo. Sound like a plan, everyone? And so Luis A. Martin, wait, no, that's from earlier. Okay, so that's the game plan. So let's go here, jump in my terminal. Can everybody see this? Okay, I think I can turn this opacity down. Let's do that really quick. How do I do this? Profiles, open profiles, default. Maybe? No? Oh, close that one. Let's do edit. I don't want to spend too much time on this, but maybe not. I was going to try to turn the opacity down, but it's fine. I'll just make sure that I go slow so that it doesn't bleed through too terribly much. Mozufer says, hi, Kris. Hi, good to see you. Oh, and Heptio says the metric server is up and running already. Okay, no need to do that bit. Okay, so what Duffy is alluding to, a little bit of context for everyone. We all know I do my alias. K is equal to kubectl. Be nice if I could type today. We can do kget nodes, which are going to show us the nodes that we have up and running. And we do kget nodes, and you can see that for once, we're not running a kubicorn cluster. We're running an EKS cluster in Amazon right now. And you can see we've actually got a lot more nodes than we usually do, and we're running Kubernetes version 1.10. And if we do our other alias here, I always do kdump is equal to k, we'll type it out explicitly, kubectl get all all namespaces, like this. We can just do a dump of the majority of the objects that are currently declared in our Kubernetes data set here. Eric says, good, kstash is much cooler with the metric server. Okay, cool. And Zolt says, hi from Finland. Hi, Zolt, welcome. Where in Finland are you from? I've always wanted to go to Finland. I have some really good friends who are Finnish. Okay, so we can see here we have a couple of pods that are running on the nodes. I'm assuming this is like they're running in kube system. This has got to be an EKS something. Like this has got to be a daemon set or something like that running on each of our nodes, running in kube system that's doing magic AWS things behind the scenes for us. We have our Kubernetes service, kubedns, and aha service metric server. Yay, already up and running. Thanks, Duffy. I should ask you to spin up clusters for us more. This is really convenient for today. You can see basically the only thing we have running in default is just our Kubernetes service that's always there, and everything else is over here on the left side in this left column is running in the kube system namespace, which is effectively root for Kubernetes. Let's see what folks are saying. Okay, so Mozufer says, is it too late here? I will watch the recording tomorrow. Okay, have a good night, Mozufer. Thank you for joining. And then Zolt says, I live in, I'm going to try to pronounce this, but is it Ulu? Olu? I think maybe the first one, but we'll see. And Josh says, kubectl, new fave pronunciation. So the story behind kubectl is when folks were arguing over kubectl, kubectl, kubecontrol. At the same time, me and Tim Hawken both, I think, came to the same conclusion based on ioctl, which is ioctl, that kubectl would be kind of funny to say. So I started saying it as a gag, and then I just got so used to saying it over the past 2 years, I've actually stuck with it, and now I just say it, and that's just what I call it. And yeah, I call it kubectl, and I think that's totally rad. Okay, let's see. Let's go back here, and let's start off by getting the metrics. No, well, let's start off by getting. Let's get Gloo installed first, and then after we have Gloo installed and running as a Ingress controller, then we can go and deploy the new dashboard, and then we might have to set up DNS. We'll see how that goes, and we should be able to get everything running. I have some DNS we can set up, so we can actually try to bring this to life on the internet, and folks can hit it from their computers at home, which will be fun. And Aaron says kubectl. I know everybody's going to say it their own special way. I have a kubectl t-shirt. I know there's kubectl. Some folks say that as well. It's just, you do you. As long as you're happy and as long as you're using Kubernetes, that's all we want. So OBS config, let's get out of here. And let's go to my Go path. And that'll be our home base for now. Cool. And let's go figure out how to install Gloo, which again, I have not looked at yet. So this is going to be fun. So here on the Gloo documentation site, which is gloo.solo.io, we have this awesome little person monster thing here that's really cute. I think it's just the Gloo thing. I don't know if they have a name, but I really hope they do. This is a Hugo site, which Hugo is a Go program that allows you to build and run static websites, and that's what we use for our advocacy site at Heptio, now VMware. And so this is the doc site that Gloo has built for us. So if you come here on the left, I wanted to check out installing Gloo and maybe even the user guides. It'll probably be the things that I want to check out. Oh, we have a question in the chat. Jan. Kris, could you please briefly describe what is Ingress and why it's needed? Yeah, totally. Okay, so Ingress, TLDR, is basically how do I get traffic, particularly HTTP, HTTPS traffic, into my cluster? And then more importantly, what do I do with my traffic after that? So when Kubernetes was very young, we had this capability of setting our services to type load balancer. And then we can map a service to various deployments or pods based on labels. And that's how we did all of our interesting mapping between the scenes. And there were some concerns about that, and we found out that it wasn't as dynamic and composable enough as we would have liked. So a really basic, here, you know what, I can do this really quick. I'll just draw a picture for you. So camera, let's see. A really basic example here is if we had a domain name. Let's say we had tgik.com. And we had tgia.com/auth. And we had tgik.com/ let's say API. And then we had another one that was like, let's call this one admin. Right? So we have all these endpoints that we want to do various things. Like maybe the auth endpoint just needs to go to an authentication service that all it does is auth. But the API needs to run whatever version of the API we're currently serving. And admin is like where all like the admin-y stuff happens that you have to have the secret password to that all the orchestrator operators can come in and play with. The point I'm trying to make here, though, is if we had Kubernetes running and we had a namespace here called the auth namespace. So we'll put this in a box here. And in that namespace, we had like, let's say we had 6 pods running. And each one of these are just running a different copy of the authentication service here. And then we want to be able to load balance across all of these so that we always know that we're always able to get a successful auth request. And we can scale this number up and down just by changing the replica set count in the deployment or however it's being ran. Now the point I'm trying to make here is if we had another one of these set up for API and another one of these set up for admin, how, using the old way, using services, you would not be able to match different endpoints to different services on the back end here. Using Ingress, we actually are able to come in and define /auth, and we're able to take this, and we're able to map that over here to this service. And then we can take API, and we can map that over here to this service, and so on and so forth, so that we're able to actually do this complex routing between various services. Now this is exciting because this helps us break down the monolith, right? If we're doing our services this way, if we want to change out our auth service, we don't have to touch the API or the admin service. So this gives us a lot of flexibility as architects and engineers of keeping our services up and making things much more resilient. So the way Ingress works is, and this is the controller pattern that we see all over Kubernetes. So this is like literally the sort of blood of Kubernetes here. The way that Ingress works, I'll draw a line, so this is a new picture down here, is you define an ingress.yaml file, which if you look here, this is an example of one here. So you would define one of these, and you would go and you would actually save that in Kubernetes, kubectl apply that, and then let's go back to my dock camera. And you would apply that, and then that would go over, and that would get stored in etcd. So etcd is here. And then we would have this other piece of software here that we call a controller. Sorry, my handwriting is sloppy. That's how you know I'm a good engineer. Controller. And then that's going to go, and it's going to do a couple of things. It's going to run this thing that we call a control loop, which basically is this ongoing, never-ending, reconcile the state of the world loop that runs over and over again. So if you check out my book, Cloud Native Infrastructure, we have this thing that we call the oh, that's annoying. We have this thing that we call the reconciler pattern. Let's see if I can fix this. And that talks a lot about the patterns behind Kubernetes and the patterns behind reconciling infrastructure in general. And that's what's going on here with Ingress. And so the Ingress controller would read this YAML file that you defined and would actually go and handle routing the traffic itself to wherever it needed to go up here, here, and here. So this is what Contour does. This is what all of the Ingress controllers do, is they take an arbitrarily defined piece of YAML that works across all Ingress controllers and then routes it differently. Now, as we start getting into networking, which we're going to be looking at today, there's going to be a lot of different concerns and a lot of different ways we can handle this, and we can mutate this or set this up in a lot of different interesting fashions. And Envoy is exactly what we need to have all of these really cool capabilities. Like, for instance, what if our auth service also was running in a second Kubernetes cluster behind the scenes, right? In that second Kubernetes cluster, we wanted to not only load balance internally across that Kubernetes cluster, but also on the second one. And this is what Gimbal does, and there's a handful of other projects that kind of help with this. But Envoy makes all of this possible because of its intricacies and how it can control traffic over the network. So the way I look at Envoy is it's just a really, really big, awesome, highly configurable, very resilient, very lightweight server that just is like really great at passing traffic. And then we as engineers just come in and need to configure Envoy and tell Envoy what to do with this traffic so that we can do exciting and interesting things like this here. And what Gloo and what Contour do is they provide an abstraction that maps Envoy that's controlling all of this type of stuff down here to this very simple YAML file and connects this very simple abstraction to the complexity of the networking stack below. Okay, so that's Ingress. That's Ingress controllers, and that's what's going on here behind the scenes. Does anybody have any questions? All right, and on that note, I'm going to grab a sip of my my Happy Friday beer here that somebody left in the fridge that I was nice enough to leave for me, so thank you for that. And Jan, again, I hope this answers your question here. And then we're going to go back and we're going to jump into the terminal in here in just a second. Happy Friday. That's how you know it's the weekend right there. Okay, cool. So back into our terminal. We want to, well, actually, no, let's go back to the docs. That's what we want to do. We want to install Gloo. And we all know I am a tab closer, so let me close all these tabs. And so now we have our markdown file. Here is the dashboard that we're going to get up and running. And then here is Gloo. So using Gloo, we can even just go really quickly read the introduction here. So earlier when I drew the graph, I talked about all the different configuration that you would care about as you're looking at routing various pieces of networking traffic to different services. And here's a list of all the features that Gloo can do for us. So we can handle TSL termination, we can handle monitoring, we can hook it up to open tracing so that we can actually see where all these packets are going. So it gives us a lot of introspection and a lot of observability into what's going on in the networking stack using Kubernetes Ingress. So that's really exciting. And then, we got some buzzwords in here, scalability and performance, but Gloo leverages Envoy for its high performance and low footprint. And if we go and we look at Envoy, so here's a really good blog. I should have brought this up earlier. That sort of explains what Envoy is and why the API is important. But if we actually just go to the Envoy docs, Envoy lift, Envoy proxy home, come down here, why Envoy features right here. Envoy is a self-contained high-performance server, that's an important word there, with a small memory footprint and runs alongside any application, language, or framework because of the API that is defined here. So there should be, so here's you can scroll down and you can see the different APIs and what they do and all the different endpoints. And this common API then plugs into this underlying Envoy code, which is all written in C++, again, thanks to Matt Klein and our friends at Lyft. And this actually makes all that happen and brings all that to life. But it gives developers this really, really convenient API. So again, we see this other pattern of taking complexity, providing a meaningful abstraction on it, and then making that whole thing lightweight. And that's really why Envoy has been so successful and why it's such a great tool that engineers choose to work with. And why, going back to Patrick's original quote here, Istio, Ambassador, Contour are all just ways of configuring Envoy on Kubernetes, which he's absolutely right. But that was a really, really short way of saying everything I just said, so I kind of broke it down a little bit there for you. So anyway, here's Envoy. You can come check out the code if you're a C++ person. I haven't written C++ since I worked at SolidFire in Boulder years and years ago, so I'm not even going to try to go look through this code right now. But it is, because it's written in C++, it's super lightweight and it gets very low level very quickly. So we're very grateful for folks who have made the wonderful API on top of this to make it easy for us to interact with. Very handy. Okay, so let's go back to Gloo. Okay, so yeah, Gloo leverages Envoy for its high performance and footprint. You can build plugins for it. There's tooling. You can even do event-based events using cloud events. You can do pub/sub, JSON to gRPC transcoding. But I think probably the most exciting thing about Gloo that I noticed, let's do Gloo Kubernetes. Yeah, I guess this is the site. Maybe it's not here. The exciting thing that I noticed about Gloo was they called itself a hybrid load balancer. Let's see if it's here at the GitHub page maybe. Hybrid. Here we go, yeah. Gloo is uniquely designed to support a hybrid application in which multiple technologies, architectures, protocols, and clouds can exist. So in other words, Gloo allows you to not only route in the same way we routed here internally in Kubernetes, but it also allows you to, like, let's say we had a fourth endpoint just called like something, we'll call it /else, and that just goes off, and that just goes to like some service in a managed cloud provider like CloudWatch, or something in AWS or vSphere Cloud or whatever effectively. And you can take TGIK.com and you can do all kinds of advanced routing now, both internally in your cluster and externally. So you can start to like look at how we're going to migrate to and from the cloud, and how we're going to start looking at true hybrid cloud infrastructure, which is really exciting because this gives us that flexibility and declarative nature of Kubernetes, and we can come in and now start to define arbitrary services using tools like Gloo and Contour, which is really rad. Okay, so let's go back to my screen. Hybrid apps, here it is here. So yeah, grep for the word hybrid, and you can see that it does a lot of things. I think one of the things folks are most excited about is this new fancy thing called serverless, which is a great example of a really unfortunate name, because there are actually a lot of servers involved, but serverless is just another way of saying functions as a service. So if you just have a very simple use case for a very simple microservice, you could write one of these small, lightweight serverless functions, and you could use Gloo to map your traffic from legacy apps to microservices in Kubernetes to these serverless functions, and manage and mutate all of that using Gloo, which is exciting. We're going to be using Gloo very rudimentarily, if that's a word, today, which is basically just going to be as a load balancer and an Ingress controller in Kubernetes. Okay, so back to Gloo. Installing Gloo. There's a Gloo command line tool, a command line tool that all Gloo users should have to make their lives easier. Well, we should install that. Unpack the oh my gosh, the Gloo-octal? Oh my gosh, what are we going to call this? I think we should call it Gloo-octal. Yep, coining it now, Gloo-octal. Brew install Gloo-octal. Okay, so let's do that. Brew install Gloo-octal. Updating Homebrew. Again, I'm on my personal laptop, so I don't use this thing very often. I usually just use my work one. So there might be some like stuff on here. Like I think I don't even have wget installed. So we might be spending some time today installing a few tools if we need them. Okay, so Gloo-octal is installed. Oh, yay, and it's written in Go. I know it's written in Go because this is clearly the Cobra command library that we see all over Kubernetes and all over pretty much every Go project everywhere. And this is one of my favorite command line tool flag parsing libraries in the world. It looks like we have folks saying stuff in chat. Let's see what's going on. Jan says, wow, thanks a lot for that explanation. Currently, we tie our services to AWS load balancer or use cluster DNS name. Yeah, so the AWS load balancers do a lot of the same things. They cost a lot of money. This is a way of taking some of that and running it in Kubernetes, which requires a little more overhead, but there's some flexibility and control that you would get it otherwise. Michael says Gloo CTL. We're going with Gloo-octal today on TGIK. Happy Friday. Love Kris Nova. So yeah, Gloo-octal. So we got that installed. Let's see what is next. Next step, install Gloo. So we'll need a Kubernetes cluster. Set up an installation for Gloo on a Kubernetes cluster. That's what we wanted to get. So Kubernetes prep. In this document, we will review how to prep Kubernetes environments before installing Gloo. GKE. Okay, so this is like where we need to set up like our RBAC and stuff like that. So far, I'm thinking GKE is going to be the one we're going to follow. Oh, EKS, perfect. And we have an EKS cluster because Duffy was kind enough to create one for us. So we can do, we suggest using EKS cuddle. Or let's see what folks are saying. Roy says, isn't CTL as in control? I use kube control or glue control. Makes it easier to pronounce, in my opinion. Yeah, I just like glue octal. That's just how I'm going to say it. Here it says we suggest using EKS cuddle, which I'm off on a tangent. But if you want to set up an EKS cluster in Amazon, this tool makes your life astoundingly easy. And the irony of it is this tool, and this was so funny, this happened earlier today, this tool vendors a lot of Go programs that I wrote like forever ago, particularly one that generates a random name for you. And the Kubernetes cluster we're using today uses this tool EKS cuddle that vendors a lot of my old code and created a Kubernetes cluster named after my old dog, Charlie. And that just made me really happy when I saw that today. So that was exciting. So EKS cuddle is an exciting tool. So it says EKS cuddle create, name your cluster, name your region. I think Duffy did a similar thing here, but probably configured it a little bit better for us. Again, thank you, Duffy. That is very much appreciated. Okay, so the next thing it says is verify that your kubectl context is correctly pointed at your EKS cluster. So we should have that already. So let's go here. And let's do kget nodes. We already did this, but yes, we are in fact talking to AWS. We can tell from the CNAME here. So let's go back, and it says use your current context. Okay, and then you're all set. Glue install guide here. So we're good. We didn't really have to do anything. Options to install Gloo via the command line interface, CLI, recommended, or via Helm. I'm going to go with the CLI here. So let's see what it says. It says choosing a deployment option for installing Gloo into your Kubernetes cluster. Gateway, Ingress. We're going to do Ingress. So install the Gloo Ingress controller to your Kubernetes cluster using glue octal. No way. No. Wow, this is really cool. So apparently all you have to do is type glue octal install Ingress. Let's see how accurate this is. This will be really cool if this is all you have to do. So it creates some, okay, let's see what's going on here. So it created some CRDs for us. So we have settings, we have gateways, we have virtual services, we have proxies, we have upstreams. So I'm guessing these are the actual concrete abstractions on top of the Envoy service proxy that Gloo is going to be using for us. And it looks like they're pretty self-explanatory. We have proxies, we have upstreams, we have virtual services, which I'm assuming are just like ways of doing dynamic routing. No resources found. I don't know what that line is from. So it created the namespace Gloo system, and then we installed the config map, ingress envoy config. Okay, so then we did a cluster role, Gloo role ingress, and then we did a cluster role binding, which again, and I've said this on a few other episodes, but folks who are just joining in who aren't familiar with Kubernetes RBAC, a cluster role defines the who, and the cluster binding defines the what. So here, we'll go back to my .cam here really quick. So a cluster, anything that starts with cluster in RBAC means that it's going to apply to the entire cluster. So that's where you get things like you can access the node object and things that aren't really relevant to a namespace. It's sort of the layer above namespace. But anyway, a cluster role is like, I want to call this, we'll call this Kris, the cluster administrator, me. And then the cluster role binding is like, I don't know if folks are familiar with like MySQL bridge tables, how you can map one entity to another, and that allows you to map that to some permission set that says, yes, we can match Kris over here to this permission set, and we might have another cluster role binding here that will map Kris to this one over here. So it's just a way of managing who can do what, and the cluster role binding is just this thing in the middle that binds one to the other. So that's all it is. Okay, so back here, so then when we created the Ingress service proxy, which, okay, so the way that Ingress works is you basically create a regular Kubernetes service, and then you map that to your Ingress controller, and then your Ingress controller then maps that internally. So there's actually like 2 layers of networking going on there. We created the service Gloo. So yeah, so this is where the traffic comes in, and then this is where we're going to distribute that traffic according to what Ingress rules we're about to define. Deployment Ingress created. So this is now, I bet if we do kget PO, dash namespace glue system, I bet we can see we have pods for all of these different deployments running in here. Let's see. Yep, and there, of course, we do. Discovery, Gloo, Ingress, Ingress proxy, Discovery, Gloo, Ingress, Ingress proxy. So those match up just in a different order there. So we are running pods. It looks like our pods are nice and happy and healthy. So, wow, that was really awesome. One command and we have an Ingress controller up and running from a statically linked Go binary. So that's really exciting. So let's go back to the docs. And it says, yeah, after you verify your installation, let's do that. Check that Gloo pod and services have been created. Depending on your install option, you may see some differences from the following example. And if you choose to install Gloo into a different namespace, you'll then need to query that chosen namespace instead. Okay, so it says just get all for Gloo system. And we kind of already did this. We already listed our pods here just naturally anyway. And then you can see we also have deployments and replica sets and services that came along with it, which we just talked about a moment ago. So yeah, so that's how we verify that it's up and running. So now let's go back and back again, and again. I think we're pretty much good. So now what we're going to need to do is let's actually get our services here and figure out where our cluster is listening on the interwebs. So we want to do kget svc namespace glue system because this is where our Ingress is deployed. And we want to do oyaml. Nope, we want to do olong or wide. What is it? I think it's dash wide. Is it o wide? Might be o wide. Let's try o wide. There we go. Okay, so let's clear our screen, run this again so we get nice, easy output. And bam, this is exactly what we want. So we've done other episodes on Ingress, so if you're curious about Ingress and how I knew to get to this step, you can go check out one of our other TGIK episodes where we talk about Ingress. I know Joe did one on Contour that was really great. I did one on traffic, so you feel free to go check those out, and those will explain in a little bit more detail how I knew to instantly run this command here and basically do the o-wide to get the name of our AWS load balancer. So let's go jump into my AWS console and see what actually happened behind the scenes here. So let's go here, and we want to go to Amazon, Management Console, log in, and then we want to go to Services. Let's go to EC2 and make sure that we're using the right user here. Nope, we need to switch over to Nova or Canova. I don't know if it's a silent K or not. And you can come in here. Oh, this is running in Duffy's Amazon, isn't it? Okay, so usually I would have my Kubernetes cluster running in my own AWS account. We're running in Duffy's right now, so we were just able to interact with Duffy's AWS account using the magic of Kubernetes, which is pretty exciting if you think about what actually just happened. I was able to create a load balancer, which if it was in my AWS account, would be showing up here under the load balancers tab. But you can see these were created March 8th, and I should probably delete those because they're not cheap. So anyway, we would have seen the load balancer created here, and that would have been mapped to the instances that we have running in our Kubernetes cluster. So we actually would have gotten a real public-facing ELB load balancer in front of our Kubernetes cluster mapped to a specific service. And then again, services can be mapped to other things based on labels. And that's defined in a lot of our other Ingress episodes if you want to find out more. Or if you have questions, feel free to ask and I can elaborate. So anyway, we should be able to grab this whole A record, and this is where things are going to get exciting. We should be able to paste it in here. This page isn't working. And so I think what's happening here is we have Ingress up and running. We have an Ingress controller up and running, but we don't have any Ingress routes defined, so there's nothing to do, there's nothing to listen on. So what we want to do is, and I'm going to jump off the screen because we're going to use my personal AWS account. Actually, let's not do that. I think I bought a domain when I was when we were Heptio. I might be able to use that. Let's see what we have here. We want to go to Route 53. We're going to actually make this thing resolvable on the real internet today. Where is Route 53? Route 53, bam. Hosted zones, tgikates.com. I knew we had one. Okay, so we want to keep our namespace records the same. We want, we can delete this record. We can delete mailing. And we want to change our TGI Kates. No, we want to add an A record. Okay, so this is awesome. So this is a very simple TGIKates.com A record, and we're going to actually look up and resolve what this address resolves to. So we can dig. Do I have dig? I do have dig. Here, and you can see, I think, let's ping this thing and see what happens. It looks like somebody's saying something in chat. Fernand says, hi, Kris. Do you know how one would set up multiple ingress controllers, i.e. serving TGI.com using multiple ingresses, and how would your failure recovery look like when a controller dies? Fernand, can you explain more or elaborate a little bit more on your use case for why you would be using multiple ingress controllers? Like, why is one ingress controller not enough for you, would be my question. Roy says, does it have integration with Cert Manager for wiring up TLS certs automatically from Let's Encrypt so it can terminate HTTPS? It did mention TLS on there. Whether or not that uses Cert Manager and Let's Encrypt, I don't know yet. We can look at that in a second, though. But I know TLS will be something that we should go at least figure out what it's advertising to do. So anyway, let's try to ping this here. Here's my mouse. So we can get its real, true public address here. So where was this thing? SVC, grab this, ping this, bam, and here is our public IP address. Yay! Hacking, right? Okay, so let's go here. Let's paste this in here, and we'll create that, and bam, poof, we have an A record for TGIKates.com that's pointed to our public IP address that should be broken. Didn't send any new data. It's not resolving just yet. And if we refresh this, let's see what we get. Bam. And then Duffy, if you're still with us, can you do me a favor? Just because there might be a concern with the AWS cloud provider. Can you check and see, if you go to your Amazon console, can you check and see your load balancer? If you go to EC2 and then scroll all the way down on the left to load balancers, you should be able to click on a load balancer that you have here, and then down here in this bottom pane, you should be able to see if it's healthy or not. Can you verify that the load balancer is in fact healthy and it says up next to it? You're looking for that magic word up, UP. That would be great if you could help out. So anyway, let's go back and let's now install, this would be so cool if it worked out of the box. Let's install the Kates dashboard. So Eric says, I thought you were supposed to use CNAME records instead of A records to point out an ELB. See, that's why I was wanting Duffy to check if it was up. I couldn't remember if the A name or the CNAME worked. So if you're suggesting we do CNAME, we can set that up. I haven't really done this in a while, so let's see what we got going on here. Let's go back to Route 53. So basically all Eric is saying, and I'm glad he mentioned something, is I created an A record here, which is a specific type of DNS record. And what Eric is saying is we should use its canonical name or CNAME, which means we didn't need to do that ping, and we can just come here and we can do our get service again, and we can do this, and then paste this in here, and we should be able to save that record set. Is not permitted. Eric says, yeah. Oh, I see. Okay, so backing up. Josh says alias the A record, and Eric says I believe that the IPs can change at any time. So let's keep that the same, and then we want to do a record set here. Let's see if this will work. I am not the DNS person. I don't do DNS anymore. DNS is hard. Is it DNS? It's always DNS. Okay, so we want to create, let's see. You know what, I bet we can just Google this. Route 53 hosted zone to ELB. Routing traffic to an ELB load balancer, Amazon Route 53. Prereqs, configure to route traffic to an ELB load balancer. If you created a Route 53 zone and ELB load balancer using the same account, skip to step 2. alias a record will work. Tega, can you tell me a little bit more about what you mean when you say alias a record? Is there like a thing in here that I'm missing? I don't see like alias a record. Give it a name. Okay. Okay, so again, there's about a 30-second delay between what folks type and what I read. So it would be really helpful to be like full complete sentence so that I understand the context. Because sometimes I'll say something and you'll respond to me, but I've already moved on because my brain works super fast like that, unfortunately. So if you could be a little more explicit, that would help me understand in which context you're exactly speaking. Alias checkbox. Got it. Oh, alias checkbox. Thank you. Wonderful. Create. The record set cannot be saved because alias target contains an invalid value. Enter target name. ELB classic load balancers. Let's see. Click A, then select radio for alias. Oh, I see. I think I see what folks are saying. Okay, so come here, select alias, save record set, enter target name. I guess tgikates.com. Let's try that one and see what happens. So I think because it's not, the ELB is not in my AWS account, we might need Duffy to do this for us. But regardless, we should still be able to hit it here. We're just going to have to use this as our host name for Ingress, right? Let's see what folks are setting. Okay, so Michael says gloo.tgikates.com. Okay, I'm all about doing that. That seems like it would make the most sense to me. So what Michael suggested is we do gloo.tgikates.com. We paste in our A record here, and we give it a C name, and this should work. Yeah. So now we can use gloo.tgikates.com, and we should get our record here, gloo.tgikates.com. And we got to, of course, wait for TTL on this. So we'll give that a minute to do its internet magic behind the scenes, and then we can go move forward with installing the dashboard. Hats off to Michael for the magic tip. Thanks for reminding me that we could do that. That was really, really helpful. And thank you for everyone else for helping with the alias stuff. I appreciate it as well. Like I said, we're doing this one completely on the fly, so YOLO. Alrighty, so let's go back to, we can close this blog. We can close Envoy, we can close the GitHub, we'll keep all this other stuff open. And let's go here and let's do getting started. I love this note that they put in here. Never trust a file downloaded from the internet. If we've said that once on TGIK, we've said it 1,000 times. And we've also said if it's we're not looking at YAML and TGIK if we're doing it wrong that week. So here we are going to be doing our classic Nova and Joe download and look at YAML in the command line that we all know and love. And like I mentioned earlier, I don't think I have wget. So yeah, let's do brew install wget. Sorry, I'm a wget user. I grew up on FreeBSD, so that's just what I like to use. Don't be hating. Looks like we have some messages held for review. So here, I can actually approve this one. So here's Michael's message. Okay, cool. Installing wget, Awesome, so now we can wget this thing here. And now we can, I think I have my Emacs. Let's see if we have my Emacs installed on here. Oh, we just have regular old vanilla Emacs. Okay, that'll work. So kind deployment, it's running in kube system. So here is, okay, so this image tells us that it's gonna pull from that Docker repo, Docker Hub repo we were just looking at. So this is good. We got a container port, 4654, a liveliness probe, timeout 30 seconds, and then of course we have a service that matches the name Kate's dash here to, if we scroll back up to the top, name Kate's app, Kate's dash there. So that's how that mapping between the service matches back to the deployment here. So this looks good to me. I think this is, we can go ahead and install this. So let's k apply -f Kubernetes Kate's dash.yaml. Poof. So deployment Kate's dash and service Kate's dash. So now let's check out our ingress and see what's going on here. Get ing dash all namespaces. No resources found. Good. So let's go back to our docs, and it says to access Kstash, you must make it publicly visible. If you have an Ingress server set up, which we're in the process of getting this up and running with Gloo, you can accomplish that by adding a route like the following. So we're going to do this. We'll copy this, and let's do, back in our terminal, Emacs, we're going to call this ing.yaml. Paste this in here. Ugh, my YAML's all messed up. Actually, wait, that's fine, right? Yeah, okay. All right, YAML is sensitive to white space, and Emacs is annoying with white space, so I always like to double check. Okay, so we should be able to kapply -f ing.yaml. Well, actually, let's edit that again. Let's see what we have here. Okay, so we want to change this to gloo.tgikates.com. And then if you look here under YAML, this is where we start to see, and this is the Kubernetes ingress, which only concerns itself with HTTP, HTTPS. And Gloo itself is actually more advanced than that, as is some Envoy itself. And you could do more with that, but in this case, we're going to be using Gloo to route to various Kubernetes services. So we're going to just basically change our host gloo.tgikates.com, and you could see here that that's just going to be on the root path, but we could actually come through and define various other paths here, and we could add multiple paths under the paths, plural, declaration here, so that we can map different paths to different service names. Remember, the service name Kstash was in that YAML we just looked at a moment ago, so that's how we're gluing Gloo together. Okay, so let's save this and kapply -f ing.yaml. Ingress created. Now let's run our kget ing command. So ing is, of course, short for ingress, and then we're going to do all namespaces. And you can see here in kube system, we have gloo.tgikates.com. And now is when we get to start debugging, or if we're super lucky, it's going to work and we all get to go home. We'll see. Nope, it doesn't work. Okay, so now we get to start debugging, which I know is everybody's favorite part of TGIK. So let's see what we have going on here. So the first way we can start to debug Gloo is we want to get the Gloo ingress controller and actually see if anything's happening whenever we hit, if we're even getting traffic to our cluster or not. So let's verify that we're actually hitting the cluster, and then we can diagnose what's going on with the cluster first. So this is the way I like to approach debugging networking in Kubernetes, is start from the tippy top and then work your way down till eventually you get to the container or the pod level. Roy said, you removed blank from path, isn't it required? Oh, it is required. Did I really remove that? Let's try. Oh, thank you. Okay, so Roy, with eyes like a fox, kapply -f ing.yaml. Okay, so we reconfigured that, and let's do our get ing, and then we'll do YAML just to verify. Kstash path is set to root. Okay, so that's what we want there. So clear my screen. Let's see. Did that work? That would be crazy if that was it. Nope. I had a feeling that was going to be too easy. Okay. So I still think something's going on with DNS. That's just my suspicion, but we're going to start to debug. Whew. Okay. So how we want to do that is we come in here to our terminal, kget kubectl get po pods namespace gloo system. And before I move on, I'm actually going to do this. Alias, we'll do kg for kgloo is equal to kubectl -n gloo system. So now I can just do kg get po. Bam. Hacking away. So we have ingress and ingress proxy. So let's grab these logs. We want to do kg logs -f. Okay, so let's see what we have going on here. So let's see. Jorn Monen says a late hi from Belgium. Hi, good to see you. And Fernand says, right, if you only have one ingress and it dies, then what? The Gloo arch pitch you've shown has multiple envoys. Wondered if you know what that setup would look like so Rex don't end up on the floor? So requirements don't end up on the floor. Okay, so for Fernand, I'll take a stab at answering that in a second. Let's finish debugging this and get it up and running, and then at the end we'll talk about sort of the pros and cons and all the different ways we could configure Gloo or Contour or Envoy and how we could start to solve the multi-cluster and multi-controller issue. And we'll talk about that at the end. Please remind me. In fact, I'm going to write a note really quick just to remind myself. Fernand's question, because that's going to be a bit of a detailed answer, and I want to stay focused on this right now, if that's okay. Okay. So if this worked correctly, we should be able to come here and do a refresh. Or even more importantly, we should be able to come here and hit this thing. Or last but not least, we should be able to come and hit the A record directly, which again, let's do a recursive search for SVC, grab this thing again, tail our logs again, put some white space in there, and empty response. So we should at least see, or at least hope to see, that something will be happening here in the logs, denoting a failure. Sorry, rex equals request touch day typing. Sorry. So yeah, again, Fernand, I'll bring up different requests, or I'll bring up your request for me to talk about multiple requests and how not to drop them in a moment. And there's some interesting patterns we can explore there. But again, that's going to be a bit involved. So let's get this thing up and running first. So let's just go ahead and let's see what happens if we ping gloo.tgikates.com. Okay, so it is going to the AWS ELB on our public IP address here. So DNS is working. So let's see what's going on in the cluster then. So let's do kdump again. AWS node, kube proxy, Ingress proxy, discovery, Gloo. I'm wondering if it's this Gloo on here. So let's do kg get PO. Let's see what Gloo itself is. Kg logs minus f. Fernand, I believe multiple envoys on the picture equals multiple instances of the same Ingress controller. Yes, I think Jan is absolutely correct. Okay, so let's see. We have some logs here. Looks like we had some event, something EDS plugin failed. That's not good. I don't know what EDS plugin is, but we should be able to come here and resolve this. And we can also, just for grins here, http:// Interesting. Jan says, have to leave now. Thanks for the episode. Yeah, have a good one, Jan. We're going to keep playing with this. Whoa, we're already an hour and 15 minutes into the episode. I did not realize it had gotten so late so quickly. Ping shows packet loss. Sure, it resolves properly. DNS client and Max are nutrious for caching DNS answers as well. Good tips. Again, we're just trying to debug here. I want to see, what I'm looking for now is I want to see if we can actually find the pod that's actually running the server that's supposed to be forwarding traffic to us and see if we can actually demonstrate that it's getting traffic. Does it require the path in the request, or is it assumed root? I think it assumes root by default. So if you don't specify, it should just go straight to root, and that's sort of like the catch-all or the asterisk of Ingress. So yeah, let's do our kg get PO. Maybe Ingress proxy? kg logs Ingress proxy minus f. Cluster manager, kates-complete. Okay, so yeah, okay, so this looks like this actually detected our route and set it up here. So let's just start out our services. So kg get SVC. Let's see what folks in the chat are saying. Fernand says, thanks, Kris. No deal if no time. ICTX Jan. Okay. So yeah, so our load balancer here, it's called Ingress proxy. So we can actually do kg get SVC Ingress proxy -oyaml. We can see here it's a service. We have some annotations, and it's mapped to the app Gloo, and it's Gloo Ingress proxy, and it's of type load balancer, listening on ports 80 and 443, which is totally awesome. And the host name is, of course, this A record here. So that should work. let's try to dig this up again. Kates, or gloo.tgikates.com. Okay, yeah, and here's our CNAME again. So that's happy as well. So let's go kg get PO, and let's do our service one more time. And let's see our names here, our label, sorry. So it's going to Ingress proxy. So that's where this is going. So now we want to do kg get PO, Ingress proxy. We already looked at this, but let's look at this again. Kg logs Ingress proxy minus F. So this should be the layer of software that's actually going to be forwarding on our networking traffic and basically behaving as a proxy, which would make sense because it's called Ingress proxy. So it updated the cluster, did some things. This looks like it's configuring Envoy. If you know that the way Envoy is set up, it's all API driven. So when you see things like this to me is a very, very obvious line from Envoy. So this is the thing that's actually an abstraction on top of Envoy itself. So this is sort of the meat and bones of Gloo here. So we really should be, I don't know if logging's just not turned on or what's going on here, but we should be able to see it up and running. And I'm really frustrated that this thing is not wanting to route traffic for us. Interesting. So let's do kget ing all namespaces, and let's just check this one more time. Ports 80, cube system, kates dash. So that makes sense. gloo.tgikates.com. So we know the traffic is going, it's resolving correctly. Ashish says kates dash service endpoints. We'll check endpoints in a second, Ashish. So we know the traffic is getting routed correctly via DNS to gloo.tgikates.com. Let's just sanity check that really quick. Gloo.tgikates.com, forwarding to our A record here. Do we need to do alias? No. Let's just do this. And actually, you know, we can just refresh a page to cancel that. Okay. So we know that's happy. And we know it's going to AB743. And if we dig again, AB743 here. So that's happy. So something's going on and it's not wanting to, are you sure the ELB is routing traffic to the cluster? Eric, this is what I was really hoping Duffy was going to help us with, if he could check out the load balancer for us. But there was that bug I mentioned earlier that sometimes an ELB will be created in the wrong availability zone and won't be able to communicate to the instance that it needs to communicate with. And that very well could be what's happening here. And that's just a concern with running any Kubernetes in Amazon. And there's some ways you can go about ensuring that, but it requires a little bit more configuration to prevent that from happening. So if Duffy, last call, I'm going to do a shout out here. In fact, I'll ping you on Slack. Hey, Duffy, can you see if the ELB is happy? So hopefully that'll get your attention. But it would be nice if you could check the ELB for us and let us know if it actually says in service or not, or it says up. So Nicholas Lane is typing. So Nick's one of our friends here at VMware as well. And let's go in here and see all of our Kubernetes resources one more time. I guess Nicholas isn't going to say anything. But either way, we can keep looking around and check and see what Gloo is doing. So, Nicholas. Oh, okay. So Nicholas says in our Slack, which you can't see right now because I have it on a different screen. He says he's on it, and he mentioned me. So Duffy's checking it out now. So hopefully we'll find out what's going on with our ELB. And Nicholas is typing again. Thank you so much, folks. This is why there's a whole crew of people that make TGIK possible. Really, every week we have like a whole line of documentation that we go through. So it's really a lot of work here. Okay, so Nicholas wants to know which ELB. So it should be the one that's created for his cluster. The ELB name, I think I can get here, kget svc, dash namespace, or we'll do all namespaces. OYAML. Okay, so let's see. So load balancer, Kubernetes, kube system. There's the metric server. let's get rid of the OYAML. We're trying to find the name of this ELB. It's going to be the one that, it's going to be the only one created that has this A record attached to it, Nicholas. So I'm going to put this in chat here. It has, for the, there you go. Okay, so Nicholas has that, so you might be able to find it. So we're just going to see if our ELB is up and running. Which, again, usually we have this on my end, but I was running a little bit late today, so Duffy was kind enough to set up our cluster for us. Okay, perfect. So Duffy comes back and says, what's up? 0.5 instances in service. Aha, so we found the problem, which is unfortunate. Might need a security group rule to allow traffic between ELB. I have it, and it's not healthy. Okay, so Duffy, I think what Eric suggested here is precisely what needs to happen. In the security group, we need to poke a hole in the firewall on port 80 between the ELB and whatever security group the instances are running in. If you could check that, that should do it. I think Nicholas Williams says, got it. I'm just like the broadcaster here. Nicholas says, got it. I'm assuming that means that they were able to poke a hole in the firewall for us, which is totally happy pandas. And let's just, like, I'm so excited. I can't wait. Let's see. Maybe here. So even after they open the hole in the firewall, AWS is eventually consistent, so it's gonna like take some time for it to do its thing. So why we're here? We're taking a break. We're gonna wait for them to get the firewall stuff figured out. I can answer your question now, Fernand, that you had earlier, and I can take any other questions if folks have questions so far. We'll try to get this up and running, and then we can close out the episode. But if you have any questions, feel free to drop them in there. Okay. Heptio says, on it, looking into the firewall thing now, 1 second. Take your time, Duffy. I'm going to rant for a bit and answer Fernand's question here. So let's scroll up in chat and see exactly what Fernand's question was. So we're going to go over here to my doc cam, and we're going to go back here, and let's pull up in chat the question one more time. So let me scroll up. Fernand, hi Kris. Do you know how one would set up multiple ingress controllers, i.e. serving TGI using multiple ingresses, and how would failure recovery look like when a controller dies? So to be clear, in this example, let me make sure we get everything here. In this example, we only have one ingress controller, but we have multiple ingress routes. So the ingress controller is down here in this part of the diagram and just reconciles all of these different YAML files. And all of these up here are just different ingress routes. So each one of these are going to represent a single one of these YAML files, which remember that ing.yaml I made earlier would effectively be one of these up here. So in this example, we're only using one ingress controller. And if this ingress controller did go down, we would run into some trouble, which is why we run our ingress controller as a deployment. And in some cases, we want to actually load balance across our load balancer so that we have that double redundancy as well. Looks like, okay, so Nicholas just messaged me in chat and says, okay, they're fixing the firewall issue. So that sounds good. Anyway, Fernand, does that answer your question about what's going on up here and the differences between the routes and the actual controller itself? Sample here. Let's see what's going on. Oh, beautiful. Thank you. Look what we have here. So let's do a refresh. Let's see what Suresh says, or Michael says. Okay. I'm doing the same on GKE, and I had to add annotation. Okay, so Michael here brought up a good thing. He says he had to add the annotation Kubernetes/ingress class Gloo. It is possible to expose the app on a different port rather than 80 or 443 using Gloo. Yeah, you can do some port forwarding type stuff with Kubernetes, but that's a little bit out of scope with this episode, but we can talk about that one later. I want to dig into what Michael's saying about this annotation. Michael, where did you add which object did you add that annotation to exactly? Kubernetes.io ingress class Gloo. So I'm assuming he had to add that to, let's pull up our terminal here. Wow, we're going to get two things fixed at once. Okay, so let's go and kget PO. I love when people help me debug. It's so much fun. Michelson says token here. Okay, Michael, if you could just let us know which object you added that to, that would be super helpful So kdump, let's get a list of everything. So we want to find our dashboard, Kate's dash here. So we want to find the deployment for that, Kate's dash. So we want, and that's in kube system. So we want to do k edit namespace kube system, Kate's dash. That should do it. Deploy Kate's dash. So we gave it the name but not the type. So the type is deployment, or deploy for short. On the Ingress, so Suresh says on the Ingress object. On which Ingress object? So are you, I guess I would need more context on why we're even adding this annotation in the first place. Which Ingress object are you talking about? The one for the Ingress controller or the one for the Ingress itself? Again, this is why I very much appreciate full complete sentences. Annotations on ing, not the most helpful comment. Change camera to desktop. Lots of stuff going on here. There we go. So anyway, I was going to edit this resource, but now they're saying we want to edit the Ingress, which, for like, the two questions are, one, where did we discover about this mysterious annotation, so that I can get the full context here instead of just asking you for this magic annotation that I have no idea about. And then second of all, which specific Ingress is it on? So Michael says for Kate's dash. Okay, so let's try this. So we're going to do kget-ing all namespaces kube system Kate's dash. Okay, so let's edit this one. So k-edit ingress dash dash namespace cube system Kate's dash. Kate's dash not found. K-edit ing namespace cube system. Oh, Kate dash. Interesting. Okay, so here in the annotations, we want to add this annotation here. Okay, so yeah, so Michael, I'll show yours, says in there. Okay, so let's back up and let's talk about what's going on here, because this got a little bit confusing for folks. Okay, so to kind of glue all of this back together, we have done two things. Number one, Duffy and Nicholas are kind enough to check out the firewall configuration in the AWS account on their end, so they should be fixing that for us now. Number two, the other thing that we're also working on is the secondary issue, which can be described here in basic Ingress. So I'm going to drop this in our doc here, and we're just going to call this we're just going to call this the annotation documentation, so that folks at home, if you're following along, you can see this as well. So there's basic Ingress. So now we can see that there, and then if we go back and we read it, let's close this. It says it here. Okay, so this is really what we should have just been looking at the whole time. And it says, let's create a Kubernetes Ingress object to route request to the pet store. And it says right here in the Ingress object, Kubernetes, blah, 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 blah. Perfect. So this explains where Michael got that from, and this also explains probably one of the many reasons why Gloo hasn't been resolving for us yet. So hopefully that kind of paints the big picture for folks. There is a tutorial here that we skipped over, and then we're going back now and adding our annotation here as well. Thank you so much for your help, and let's add it here. Kubernetes.io Ingress class Gloo. So that looks happy, so we should be able to save that. It was edited. Let's see. Okay, let's go back here, and let's go here. Still nothing, still nothing. That's okay. I'm hoping that they're just working on the ELB right now. Which, by the way, Duffy or Nicholas, if either of you could give us an update on the ELB, that would be super handy dandy. But if not, it's totally okay. So let's go back and let's look at this, this ingress routing here. So it says we need to create an ingress object. Here's an example. It says path is /.star. Fernand says, awesome, you rock. Thanks, Kris. Makes sense now. I was confused with traffic. Suresh says there's no default ingress controller in Kate's, thus we need to have this annotation, in my opinion. Thank you, Suresh. We might want to steal this little syntaxy bit here. and add that to our ingress. Let's try that. 505 in service. Woo, awesome. Okay, thank you, Duffy, and thank you, Nicholas. And so now, while we're here, let's edit our ingress again. And we're gonna go all the way down here to the bottom to path, and we're gonna paste in that magic line there. And we're gonna close that. And now we're going to come up here to gloo.tgik. Yes, it works. Sorry, I get really excited. Okay, so yeah, a whole team of people working together to get gloo.tgik.com, and it says enter your auth token here. So yeah, now everybody on the internet is going to be blowing up gloo.tgik.com in our AWS account. Please be nice and don't do what I did one time to Joe and shut your company's internet down by spamming the TGI Kate's broadcasting stream with all kinds of traffic, which that was a really fun episode as well. Okay, so let's back up and explain what's going on here. So we created a Route 53 DNS record here. We created a CNAME record, and we gave it the prefix gloo.tgikates.com, and we wanted to create a CNAME so that we could point it directly to the A record for the ELB, the Elastic Load Balancer in Kubernetes. So after we had that, we were then resolving public traffic, but the ELB that was created in an AWS account that I don't have access to was not resolving to the traffic to the instances it was supposed to be. Use a token from your kubeconfig. Thank you very much, Duffy. And so anyway, I'm assuming, and Duffy, correct me if I'm wrong, but folks at home are probably a bit curious about what was going on with the ELB, but I'm assuming it was either the security group or it was in the wrong availability zone. Any of those would be helpful. So Roy says it supports Cert Manager. Okay, so Roy answered his own question. So then after we got the ELB up and running, we were then routing traffic. So then Route 53 kicked in. Then we passed the traffic off to, let's go here, back in the terminal. We passed it off to kgetpo, or we can do kg get po. We passed it off to the Ingress proxy in this namespace, so kget logs. Blah minus f, and this is the actual abstraction layer on top of Envoy that is Gloo itself, and now we're resolving traffic to the Kubernetes dashboard. So we want to get the token from our kubeconfig, then I suspect your annotation also helps. So yeah, I think this is totally an example of like, one, it's okay, Kubernetes is hard for everyone, but that's why we do these TGI cases so we can learn together and we learn more about Kubernetes along the way, and then so we can show folks exactly how we are able to solve a lot of these issues and hopefully speed things up for both people internally and for all of our followers at home and across the world. So let's see what we have now. So we want to grab the token from my kubeconfig. So I want to do that by creating a new tab and getting that off the screen. And I want to come over here, and I want to do I'm just going to type out what I'm typing, even though I'm doing it off the screen here. I want to do a cat home directory kube/config. And we're going to copy my token here. Bam. Minimize this. Let's see what folks are saying in chat. Let me just really quick say thank you to Nicholas and everyone else. And let's go in here to the Slack. Or not the Slack, I'm sorry, to the dashboard here. And let's paste our token and see what happens. Go. Never, not now. Okay, cool. So we have the new Kubernetes dashboard up and running in Kubernetes with Gloo as an ingress controller, serving traffic distributed across our deployments, all running in Amazon, and it only took us an hour and a half. So not so bad. But again, this is why I usually like to go through things before the episode, but I also really like the episodes too, where we get to do some live debugging together as a team, because it's always fun to see how this stuff comes together and to work together as a team. So anyway, let's check out this dashboard and see what we got going on here. So we can see we've got 5 nodes, which is cool. We have 18 pods. So this is like the cluster overview, like what's going on in my cluster. Oh, this is really cool. So these are like the oddity logs, right? So we can see like things that have happened. Somebody pulled the kube system kate-dash, which this was me. And then you can see we created a container called kate-dash. Again, this was me. So this is like effectively a record of everything that I've been doing on this episode of TGIK to get Gloo up and running. So this is really cool. And if we wanted to come through and actually see some of the steps we did earlier, we could see like, here's where we created the Gloo system Ingress and so on and so forth. So that's exciting. We're getting to see a bit of history in our cluster. Let's go over here to the left and let's click on nodes. Ooh, I love graphs. Let's see what folks are saying in the chat. Victory. Awesome debugging. Thanks, everyone. We really appreciate it. Roy made his comment about Cert Manager, which we'll look at TLS in a moment. I want to go through this dashboard really quick and just see how this thing totally works and see what we have going on in here. Okay, so it'll show us our labels on our nodes. It does like a top thing so we can see if it's ready, which this is an important part of like what the cluster API does, is that we always want our nodes to be ready. We're using 6.7% of our compute, only 5% of our RAM, and we're going to get to see like, oh, look at this node over here. This one's actually working harder than the others. I bet this is doing the metric server or something exciting. So we can come in here to namespaces. Here we have the default namespace. We have kube system, kube public, as we all know is a newer one, and Gloo system, the one we just created. Let's check out our workloads. Kubectl get events. The graphs are brought to you by the integration with the metric server. Yes, so this is why folks are saying it looks way cooler if you have the metric server up and running. So this is really exciting that we can come through and see all these graphs and get all of this wonderful, all these wonderful metrics, because the metric server standardizes that for us. Once it's up and running, we can just gobble those up and just regurgitate them on the page, which is what this new and improved dashboard is doing here. So yeah, I'm not going to spend too much time. You can come through. You can see we have services. You can see our replica sets, pods. Here's all of our various ingresses, and this will tell you the path that the ingress is running on. So this just gives you like everything I was doing here. Let's pull it up. All of the command line hacking stuff I was doing here, we can now get all of that same information here from the dashboard. It's a lot easier for us, and we can come through and we can like copy and paste stuff directly out of the dashboard. We can see our various configs. We can look at if we have any storage. We can even create various profiles and accounts, and here's all of our RBAC stuff as well. So can we actually edit this stuff? Oh, you can. Okay, so this is really cool. This is like an inline editor. So you can really come through and edit and configure and play with your cluster here using this open source dashboard. So this is really cool. And Gloo is bringing all of this ingressy stuff for us here. So this is quite exciting. Okay, so real quick, right at the end, let's go back to Gloo. Dum-dum-dum. And I bet if we go to user guides, is there setting up TLS? Bam. Let's just see what this is here. So you would do gloo octal, get upstream, default pet store. You would add a route. You can use virtual service. Okay, so this is going to be a lot to set up in this episode. Maybe we can do a secondary episode if folks want to see it. But it looks like you can totally come to and set up TLS so you can get TLS running with Gloo as well. Michael says, very clean dashboard. Nicely done, everyone. Gloo looks way cool. Awesome. So I'm going to do the thing I do at the end of every episode where I go here. And this is how you know our episode is coming to an end. And it's time to say goodbye. And folks can start enjoying their weekend because I went back to my full face here. So anyway, it's been a great episode. Again, shout out to everybody in Kubernetes who make all of this possible, all the hard work that went into the dashboard, Gloo itself as a server. Shout out to Nicholas and all the folks in the Bellevue office for helping me out today. Y'all really saved the day. Thank you to Ashish and Michael and a handful of other folks who helped us find the annotation we needed to add and helped us with the CNAME earlier. It's been a really fun episode. Let's see what Eric says. Just to be clear, the dashboard isn't the new Kubernetes dashboard. This is a project I've been working on for a couple of weeks, so I'd love for it to become the new dashboard. Sorry, that's what I was implying, Eric, when I said the new dashboard. So this is, I'm going to go on a bit of a tangent here while we're at the end of the episode because it's Friday afternoon and I'll have my second sip of beer. So what Eric is saying is this is a project he built on his own. So it's not like official. Remember earlier we looked at the Kubernetes core scope, what isn't out of scope. So all Eric is saying is like he built this and he hopes folks can use it and it's really cool and we really like it as well. But by no means when I say the new Kubernetes dashboard does the word the imply anything official. This is just like a project, right? Just like Kubicorn has nothing to do with Kubernetes. It's just a project I created in my free time. It's a project that I obsessed with like over a year, but it wasn't officially a part of the Kubernetes core or the Kubernetes SIG code responsibility. So anyway, just clarifying that for Eric. Suresh says, thanks, Kris. Julian says, thank you for teaching us. Zolt says, awesome as always. Thanks. Fernand says, thank you, Kris. Sandeep, thank you, Kris. Y'all, I really do love doing TGIK. I really love hanging out. I love hacking. I love that folks come and get involved and help me out. It's always a ton of fun. Thanks for making this so successful. If you're going to be at KubeCon in Barcelona, come check out mine and Joe's talk. We were talking about it earlier today. We're really excited. We're going to have a few surprises for you. Now that we're VMware, we're going to be growing TGIK a lot more, and we're really excited about what the future of TGIK is going to look like and how we're going to be able to make this content go even further and make it even more awesome for folks as we grow and as we become this new great entity. So we're really excited about that. So Martin says, great walkthrough, Kris. Bjorn says, thanks, I'm going to watch the whole recording tomorrow. Have a nice weekend. Okay, so last chance. Questions for me, questions for Ingress, anything else folks want to say? I'm going to grab a sip of beer, and it looks like since we started the episode, Mount Rainier, a.k.a. Mount Charlie, a.k.a. Tahoma, has decided to come out, and so now I'm live on the air staring at my favorite mountain with all of my favorite people drinking a horrible beer. So anyway, thank you from Michael, and she says, thanks for the episode. Okay, well, happy Friday, everyone. Enjoy your weekend. Pat yourself on the back. I'm sure you all did really great hard work this week. Keep it up, and we will see everyone next week with another exciting episode of TGIK. I think Joe's going to be doing it, so we'll make sure to have a good time with Joe and make him feel welcome because we don't get to see him very much anymore. So if you want to hang out with Joe, he'll be back. He always does a really great job. And I am your host. Thanks for joining about Gloo and the Kubernetes dashboard. I'm Kris Nova. Bless, bless. Happy weekend, everybody.